In this lesson, you will learn to apply the definition of a parallelogram and the theorems about properties of a parallelogram. Now, as we begin, we first need to define what is a parallelogram. Well, a parallelogram, by definition, is a quadrilateral with both pairs of opposite sides being parallel. So we see here the left and the right side are parallel, and the top and the bottom are parallel. And if we understand the word parallel, then the name parallelogram makes sense because it is a shape that has parallel sides. Now, when you name a parallelogram, you name it the same way you would any other polygon. So we start with the letter. So let's start with the letter M, and then you go either clockwise or counterclockwise. So if we go clockwise, we then get to letter A, then to H, and then we get over here to T. So we can write this as parallelogram MAHT. And notice the parallelogram symbol. The symbol is simply a small parallelogram written next to the letters. Now, there are properties of parallelograms that you need to be familiar with. The first property says the opposite sides of a parallelogram are congruent. So, for example, we have MA and TH. Those are opposite sides. And with a parallelogram, those would be congruent, meaning they have the same measure. And then the other sides, MT and AH, would also be congruent. Another property is that the opposite angles are congruent. So you're looking at angle TMH. So So that would be angle TMA. So this angle right here would be congruent to angle THA, which is this angle. So those angles are across from each other. And then angle MTH right here would be congruent to angle MAH right here. So the opposite sides are congruent, the opposite angles are also congruent. A third property of parallelograms is that the consecutive angles will be supplementary. So consecutive means angles that are next to each other. So for example, angle MTH, this angle right here, and angle THA, this angle over here. So these two angles would be consecutive, and it says that consecutive angles will be supplementary. So they're supplementary, meaning if you add them together, they're going to be 180 degrees. And that one makes sense based off what we know about parallel lines, because if we look at this parallel line, MT, and then the line AH, you kind of extend that a little bit, and then looking at this transversal cutting through, we see that angle MTH and angle THA are both same side interior angles. And we have learned previously that same side interior angles with parallel lines will be supplementary. And the other consecutive angles, angle TMA, so TMA would be right here, and then angle MAH up here, those two would also add up to be 180 degrees. A fourth property that we have with parallelograms is that the diagonals will bisect each other. Diagonals are segments that go from one vertex to the opposite vertex. So your diagonals in this case would look like this. And they meet here at point O. And so this property says that the diagonals bisect each other, meaning that MO right there and OH would be equal. Or you can say the segments are congruent. And then also TO equals OA. So TO and OA are the same measure. So to recap everything, first property is actually the definition, and it says if we have a parallelogram, then the opposite sides are parallel. That is by definition. And then we have opposite sides are congruent, opposite angles are congruent, the consecutive angles are supplementary, and the diagonals will bisect each other. So make sure you have these memorized because you'll need them to answer questions here in the next few moments, as well as this will be important in the next lesson where we are working backwards and trying to determine, do we have a parallelogram or not? So now using these different properties, we're trying to find x, y, and z. So starting with angle x. Angle x is an opposite angle to angle A up here. So we said that with parallelograms that the opposite angles are congruent. So x must be 75 degrees as well. And then to find y, we know that same side interior angles, or I guess consecutive angles in this case, are going to be supplementary. So if I take 75 plus y, those are consecutive angles. So those added together would give me 180. So y would have to be 105 because it adds with 75 to get 180. So y is 105, and then the opposite angle across from y over here would also be 105. And then to find z, we know that if we add 105 with angle z, we get the entire line, and a line has 180 degrees. So if I take 180 minus 105, I'm going to get 75 degrees for angle z. Or we could have also gotten 75 degrees by using the fact that we have a parallel line here on the top and on the bottom. And this line would be your transversal cutting through. And the 75 degree angle and angle z would be alternate interior angles, which with parallel lines, the alternate interior angles would be congruent. So either way, we got 75 degrees for angle z. Here's another example. We're trying to find the values for x and y. So let's start by thinking through what we know. This angle is 100 degrees down here, and the angle across from that, the opposite angle, would also be 100 degrees. Okay, we also know that consecutive angles will be supplementary, meaning that if this angle is 100 degrees, then this angle up here, the consecutive one, would add with that 100 degrees to give me 180. So I know that entire angle must be 80 degrees. And if this one part of it is 40 degrees, then y must also be 40 degrees. So y is actually easier to find than angle x. And then angle x, to find this one, we would use the fact that we have a triangle up here on the top. So looking up here at the top triangle, we know a triangle has 180 degrees. So there's 100 degrees right there, 40 degrees right up here, and then angle x would have to add with that to give me 180. So 140 plus 40 would give me 180. So x would be 40 and y would also be 40. Here's another example. We're told that MO equals 4, and the question is, what is MH? So if MO is 4, we know that we have diagonals here, and with parallelograms, the diagonals will bisect each other. Meaning that if M to O is 4, then from O to H must also be 4, because it's being bisected. So then the length from M all the way to H would be 4 plus 4, which would equal 8. And that concludes our lesson for today. We will see you next time.